Today in Honors Pre-Calc, we are going to be covering how to solve systems with three variables. We are covering Unit 7, Section 3 today. The key to working with three variable systems, there's a lot of different ways to learn how to do these. You can do them with substitution, elimination. The most success that I've found with working with three variable systems is to organize it with elimination. So your goal is to take three variables with three equations and to sort of condense it down. The first thing that we are going to do is we are going to pick two combinations and try to condense three equation system down to two equations with only two variables. We're going to do this by eliminating a variable. So I'll usually sort of look for something that's easy to work with. For example, equation 1 and equation 2, I think I could get rid of the x's really quickly, or even the y's really quickly. So let's start there. We are going to select equation number 1. And let's go towards the y's. We're going to take equation 1, which reads 2x plus 3y minus 4z equal to 20. And equation 2, which reads x minus y plus 5z equal to 13. And let's aim to get rid of the y's. They're already opposite, so let's make them equal. We're going to go ahead and multiply equation 2 by 3. We'll just recopy that first one. And then we'll go ahead and multiply by 3 minus 3y plus 15z, and we'll get a 39. And so when I go ahead to add my equations together, I would only be down to one equation with two variables. We'll have 11z and we'll have 59. So we'll call this one equation 4. And we're going to come back to that one. Now you want to pick two more of your equations, and you want to go ahead and combine them again. You have to choose different ones. We can't pick 1 and 2 again. And you want to get rid of the same variable. So here, I'm going to go with equations 2 and 3, and I think that's a pretty good choice because I can get rid of my y's very easily again. Again, they're opposites already. I would only have to multiply equation 2 by a 2, right? And that would give me equal and opposite y values. So we're going to take equation 2, which currently reads as x minus y plus 5z equal to 13. And we're going to go ahead and double it. That would give us 2x minus 2y plus 10z equal to 26. And we'll combine that with equation 3. I don't want to write it twice. Let's just move it over here since we don't have to edit that equation. And we'll recopy that one so that we're ready to add. Right? We've chosen two different equations than our step 1 here, but we've managed to eliminate the same variable. So you don't want to eliminate different variables. You'll make a mess. And we're going to get 5x plus 14z, and what do I have? 41. And so let's call that one equation 5. When you're doing your homework, you don't have to label them this way. It's just a way of keeping us organized here at the beginning. Okay, so once you've done that, you've taken your three equations, picked 2, gotten rid of 1, so you're down to a 2 equation with 2 variables. You're down to 2 equations with 2 variables. You're going to combine those 2 equations into 1 variable. So in step 3, right, we're going to take our results. We're going to take equation 4, 5x plus 11z equal to 59. And in order to make them equal and opposite, right, I have the 5 and the 5. Let's multiply this guy here by a negative 1. So minus 5x minus 14z and minus 41. Essentially, we're subtracting instead of adding. And what happens is that my x's will cancel. And I'll get minus 3z and 18. That means that z should be negative 6. Right? But I could take that back and I could plug it into either equation 4 or 5. Either one of them would work perfectly fine. And I could now solve for which variable? I could solve for x, right? So let's just grab this one since it's close by. They're both about equally as terrible in terms of multiplying. We would have 5 times x plus 14 times negative 6 and 41. So I'm plugging the variable that I managed to solve for back into either equation 4 or 5. Here I chose equation 5. So that's going to give me 5x minus 84 equal to 41. I'll add that over. It gives me 125, and I've solved that x is 25. Once that's done, right, I'm still missing one variable. I've got to go back and solve for y. You can pick any of the equations at the top. You have 3 to choose from, right? If you now know x and you now know z, you could go back and pick any one of them, and you could solve for y. I'm going to pick the middle. It, to me, just looks the easiest, right? I have the least amount of multiplying to do. So I'm going to choose to select x minus y plus 5z equal to 13. And now, knowing what I know from step 3, I can plug in a 25, and I could plug in minus 30, and I could go ahead and solve for my y value, right? We've got, let's see, negative 5 minus y equal to 13, and I could subtract the 13. I'll get negative 18 equal to y. And so now you've done it. You've worked backwards. Elimination, just a multi-step process here for these 3 variable systems. And you want to report your solution as you would in 3 coordinates. You'll always go x, comma, y, comma, z. That's our convention. You want to still report them as coordinates, this time in the 3D plane. All right, I don't think we're going to finish the second example in this first video. So go ahead, flip the page, and I'll meet you in video 2.